given a triangle with various lengths, which I will add on a bit later, not right this second. We're then also told that the bisector of angle ABC intersects the side AC at D. So that means that these two are the same. Because it's a bisector, it's splitting an angle into two. They must be the same either side. And the line through A, perpendicular to BD, intersects BD at M. So if it's perpendicular, well, they've already drawn one right angle on, but all of these will be right angles. We're asked to prove that M is the midpoint of AP. Now let's take a look at these triangles. So I've got ABM in green. And I'll just draw it out over here. So I've got a right angle, I've got this like blue angle. And I'll just label on A and B. And then I've also got this purple triangle, which I'm gonna kind of flip around so it's the same orientation. So now I would have, yeah, B here again with the same angle. And then the right angle is again at M, and then this would be P. Now we have two equal angles. The blues are equal and the 90s are equal, and we have a side in between that is the same. It's a shared side on both triangles. So we can say by angle, side angle, triangle ABM is congruent to triangle BMP. You can write it in words as well if you prefer. So that means that AM must equal PM. They are congruent triangles. It means the angles are all the same, the sides are all the same. And we can see the corresponding sides would be AM and PM. And therefore, M must be the midpoint of AP because it's the same distance to go from A to M as it is from M to P. That is the definition of the midpoint. So that one is sorted. Find the length of PC, justifying your answer. Okay, I'm now going to add on some of the side lengths. We know that AB is 85. We know that BC is 160. And we know that CA is 103. But what we've just shown, because of the congruency, is that AB is also going to be the same as PB, which means this length is also going to be 85. We actually have an isosceles triangle when we put the green and the purple ones together. And we're there basically at that point. So if I want to find PC, it's going to be 160 minus 85, which gives me 75. So that is my answer for B. We're then told that a line through A, perpendicular to the bisector of angle ACB, intersects it at N. Okay, let's just try and get that down. A line through A, perpendicular to the bisector of angle ACB. So first of all, I'm just going to draw in the bisector. It's only a sketch now, but that looks like it's splitting it into two. And then a line through A, perpendicular to that, intersects it at N. So I'm going to draw a line coming down at right angles like that. This is 90 degrees. This is going to be N here. And we're being asked for this distance. Okay, I'll remove it for the moment, but that is what we're looking for. Now we can make very similar arguments here as we did in part B, and you should write them down in words, but we've got another angle bisector, so these two are the same. I'll do a little kind of double rings to show that. Again, we've got right angles in both triangles, and then a shared side. So this triangle in purple is congruent to this triangle in orange, again through angle, side, angle. And what that tells us is because this here is 103, then here to here is also 103. Now, how to use that to get NM? Okay, well, let's try and use all the information that we have. Remember, we've worked out PC. That there is going to be 75, which means we now have P to, I haven't actually labeled this anything. Let me call it X. So PX is then going to be 103 minus 75 is 28. Okay, brilliant. So what we now have is a length of 28 along the bottom. I think I'm gonna bring this down, just draw it. It's just not quite enough room. Okay, so if I just draw this triangle out in isolation, then I've got this X, P, A. I've just said that this length here is 28. But oh yeah, I wrote it below. Okay, that's 28. And then I know that M here is the midpoint. No, I didn't say this before, but n is then going to be the midpoint of x for the same sorts of reasons, because we've shown that the purple and the orange are congruent. That means that xn equals na, and therefore n is also the midpoint. What that is actually going to tell us, if we're going halfway up, is they're going to be in line, because as you go like halfway up here, you go along halfway up the height. So I'm going halfway up the height to get to n, but I'm also getting halfway up the height to get to m. And therefore, this and this are these two are parallel. So if I just say that the total height is h, and then for this smaller triangle, these are nested triangles now, it's going to be a half h. These are similar triangles because look, they share this common angle. Because of the parallel lines, this must be the same as this, and this is the same as this. So the triangle at the top in blue is just half in lengths of the bigger triangle, which means all I need to do is do 28 divided by 2 to get NM, and our answer is going to be 14. So nice question here. It's actually, I mean, if you can do it, if you can see that, it's very quick. There's not like loads of calculations. But of course, it's like realizing to do that, it's drawing on the diagram and not having it get too messy. Um, what I'd say is like definitely just make a replica of this diagram, draw it nice and big, because you are going to have to get things on there. Work, follow the steps. It's kind of guiding us along, but yeah, it's a really nice result. We can work out the distance between N and M using the similar triangles in the previous results. Good question, well done. Just one final comment before someone tells me I'm wrong. I did get the wrong symbol for congruency here. I just forgot what it was, but it's an equal sign and then a little kind of tilde above. So I shouldn't be using the identity symbol. It should be that to say congruency, but feel free to just write it in words that triangle ABM was congruent for triangle BMP. If you're writing full written solutions, you should be doing a similar thing for this case here. I skipped over that. It's the same kind of argument for the congruency, but we could also say that triangle ACN is congruent to triangle XCN using the angle side angle, and that's what allowed us to then work out some of these other sides.